Hello friends, welcome back to the next lecture. In the previous lecture on public transportation, we got some introduction about it and learnt about some benefits and what are the issues facing public transportation in India. So, today we are going to take it forward and move to the next step where we are going to introduce you to the basic operating elements in public transportation. So, the concepts to be covered in this lecture include some basic definitions and formulas for lines, stops, networks, how do you define transit right of way, what is a vehicle, what is a transit unit, and some operational factors of public transportation including headway, frequency, capacity and utilization. These are very specific terminologies that have to be remembered in case of public transportation. As we move forward, we will be doing solving some problems and so on and so forth. So, good deal of attention needs to be paid for these terminologies. So, let us begin. The first and the basic terminology in any transportation, in any public transportation system is what is called a transit line. So, we all have taken several public transportation systems maybe across different cities and we always know that there is a public transportation line which we need to take. So, how do we define a public transportation line? It is the infrastructure and service provided on a fixed alignment by vehicles or trains operating on predetermined schedules. So, these are vehicles or trains operating on predetermined schedule and on a fixed alignment. So, usually what happens is you can see in the picture given on your right side that there are several different lines that you can take to go from point A to point B, such as yellow line, green line, red line, so on and so forth. So, this is an example from the Pune bus route map. So, if you had to go from point A to point B, you would pick a line given other characteristics of that line. So, that is basically what we call as a transit line. And sometimes transit line and transit route are synonymous to each other, whereas a transit route usually designates street transit rather than metro or regional rail lines. So, street transit meaning they have to be operating, if they operate along with other transportation modes such as cars and auto rickshaws and so on and so forth, then they are called street transit. So, when it comes to street transit, we call it transit route rather than a transit line. So, in the same example, if it is a bus route, so we will call it, these are all the different routes. So, blue route, orange route and so on and so forth. The next terminology to remember is a transit network. So, there may be different lines, there may be different routes in a public transportation system, and what a transit network says is that transit network is a set of transit lines that connect with or cross each other in a coordinated way. So, the transit network comprises of several transit lines or transit routes. So, here you would see again a map of the rail transit network in Istanbul in Turkey. So, you would see that there are several transit lines. Some of the lines run parallel to each other, whereas some crisscross. So, the crisscross is by design. Okay. So, crisscross is not accidental or due to different alignments coming to meet at one point, but they are actually designed in such a way that people can move efficiently from one point to the other in the city. So, that is what is a transit network. So, all of these lines collectively would represent a transit network. Then the next terminology to remember is line length. So, when we have so many transit lines, we have to remember what is the length of a particular line. So, line length is defined as the one-way distance between the two terminals along the line, usually expressed in kilometers or miles or whatever the unit is. So, if you look at this map, you would see a black line at the bottom of the map which runs from a point in the westernmost point to an easternmost point, and vice versa. So, you can call that or you can calculate the line length of the black line from the terminal that is in the easternmost side to the terminal at the westernmost side. So, between the two terminals, the entire length of the line is called the line length. So, these are all operational terminologies that help in scheduling a bus service or a rail service. So, once you know that your transit line is n kilometers long and you have s number of stations in between, so you can then schedule your transit line accordingly. So, moving on, next is what is called the network length. So, now you know the line length. So, in similar way you have to now determine what is the entire length of your network that is within the city. So, the network length is intuitive and easy to define, is the length of all alignments served by one or more lines. So, you have multiple lines, then what is the length of all of those lines added together. A similar sort of a terminology is called total line length, and we will see how it is different from a network length in the example that is following this definition. So, total line length is the sum of all the line lengths regardless of whether they operate alone or overlap with each other. So, there may be some overlapping lines. However, when we calculate the total line length, we will calculate all those overlapping lengths as well, whereas when we look at network length, we usually do not consider the overlapping lengths. So, that is the difference, subtle difference between a network length and a total line length. So, here in this example, you would see that there are essentially there is a red line going from terminal A to terminal C, there is a green line going from terminal E to terminal F, and then there is another blue line that also starts from terminal A, but goes to terminal D. So, there are these essentially three lines, but they are crisscrossing at different points. So, if you were to calculate the line lengths, the individual line lengths, then you would say that line length AC for the red line, the line length would be 6 kilometers, given that every station is equally spaced and it is 1 kilometer each. So, if you see then you could calculate that the line length AC is 6 kilometers. Similarly, the line length AD, which is the blue line, is 5 kilometers, and the line length EF is 7 kilometers. So, now when we want to determine the total line length or the route length, what we do is we add up all of these line lengths individually. So, irrespective of whether these two lines, which is the red line and the blue line, that are overlapping for one stretch between A and B, we still add all those lines up and say that the total line length or the route length is 18 kilometers. Whereas, when we look at the network length, you would see that we are adding AC, we are adding EF, but now we are not adding AD, but we are only adding BD. So, we are neglecting or we are not adding the overlapping section, and we are only adding the section that is not overlapped. So, then we get a network length of 15 kilometers. Hopefully, that is clear. Now, we move ahead. Now, when it comes to right of ways, we define the transit right of way is defined as a strip of land on which a transit line operates. Okay? That is simple enough. However, it can be classified into three other subcategories. Okay? So, category C, B and A. So, what we essentially see is that category C is a type of a right of way where a surface street with mixed traffic exists and the transit runs on that surface street itself. Okay? So, category C is a surface street with mixed traffic. So, that if there is that kind of a right of way, then we say that this is a category C right of way. Whereas, when the right of way are longitudinally separated from other traffic, we call them as category B. So, what do we mean by longitudinally separated? So, maybe there is a median on which a public transportation line runs. So, the median is separated from the adjacent vehicular traffic by some sort of a tree line or some sort of a different pavement type. So, that is, but they are still running on the surface, the transit line is still running on the surface. So, such type of right of ways are categorized as category B right of ways. Whereas, category A right of way is a fully controlled right of way without any grade crossing or any legal access by other vehicles or person. So, when we see the metro lines usually that are over ground or above ground, such kind of right of way for the transit or public transportation is categorized as category A public transportation. So, category A right of way, sorry. Now, if you look at this chart, and we would not go in detail in this chart, but that we would do it later. But this you would see that the x axis has the system performance, whereas the y axis has the investment cost per line length of any system. So, you would see that if it is category C type of right of way for any public transit, you would see that the cost is very low, the investment cost is very low, but the system performance is low as well. So, to introduce in other words, we can say that to introduce a bus transportation in any city, it may cost very less, but at the same time the system performance would also be very less. What do we mean by system performance? Schedule, staying on schedule, staying on time, all of those things, and we will look at it in much more detail later on. So, similarly, now if you move on to right of way type B, the cost increases a little bit as well as the performance also increases. However, then when we finally move on to right of way category A, that has the largest cost and the most good system performance as well. And the breadth of the boxes say that what is the range in the system performance and the range in the costs. So, that is that kind of gives you an idea of how the right of ways are categorized. If I wanted to show it in pictures, you would see that the first picture on your left is a right of way category C, where the bus is traveling along with all the other vehicles on the street. If you move anti or clockwise to category B, that is the picture of a tram which has its own right of way. So, it has its rails that is its own right of way, but the rails are at grade with the other modes of transportation. So, although it has its own right of way, but it is running with mixed traffic. Whereas, when it comes to category A right of way, they are usually the metro systems or the subway systems across various cities in the world that have category A right of way. Now, let us move on to the other types of operating elements that are involved in public transportation and which you have to know. If the first thing is a transit stop. So, we all go to a designated place on the road to avail any type of public transportation. So, a transit stop is a location along a line which transit vehicles stop to pick up or drop off passengers. Easy enough, this can be easily identified by various infrastructures that are in place at these locations, such as sign, benches, shelters, etc. And a picture on the top is illustrating the same. A transit stop and a transit station are synonymous to each other in the way that both of these are locations where transit vehicles pick up or drop off passengers. But a transit station is a special structure that facilitates passengers boarding, alighting, waiting and transfer. So, whereas a transit stop could be a point in a line, whereas a transit station could be a linear feature along that line. So, it has some more sitting facilities, it has variable information available, it requires a little bit more infrastructure to actually accommodate the public transportation vehicles. And usually we call if they are rail public transportation systems, and we usually call those stops as transit stations, whereas if it is a more rubber tired or bus type of public transportation system, we call those kind of stops as transit stops. So, both of them are similar, but just a little bit of difference in terminologies. Now, when we look at transit stations, there may be two different types. One is a terminal station and one is a transfer station. So, terminal stations are strictly defined and stations on the transit line, end stations on the transit line. So, like we looked at the map earlier of the rail transportation network in Istanbul, Turkey. So, along those black routes, along the black line length, along the black line transit line, we saw two terminals, one on the east and the one on the west. So, those two stations or stops are called as terminal stations, whereas there may be other stations where people could transfer from the black line, for example, to the other green or blue lines. So, such stations are called transfer stations, and they are joint stations for two or more lines at which passengers can transfer between transit lines. So, a transit station could have two different classifications as well. So, if we go back to our sketch of the transit route network, we would see that stops or station numbers 1, 2, 3, 4, 5, 6 and 7 could be called stops or stations. So, all the blue dots and the two small orange dots could be called as not the two small orange dots, but all the blue dots could be called as stops or stations. Whereas, the terminal stations are the ones noted in square and has an alphabet inside the square. So, A, C, E, F, D. So, these are the terminal stations. So, you will see that they are the end of any particular line, whereas the transfer stations are the ones where people could transfer from one line to the other. For example, the station B is a transfer line, the station 8 is a transfer line, station 9 is a transfer line. So, on station 8 one could transfer from the green line to the red line, whereas on station 9 one could transfer from the green line to the blue line, and on station B one could transfer from either the red line to the blue line or vice versa. Okay. So, that is a graphical example of what do we mean by different types of stops and stations. Now, the next thing to know is about the vehicles and the transit units and the fleet size. So, transit unit is defined as a set of n vehicles coupled together. So, this is the basic unit when we talk about any public transportation system. It is called TU in short. So, transit unit is defined as set of n vehicles coupled together. Now, buses usually operate as single vehicles. So, in this case n will be 1, whereas trains are coupled together to achieve greater capacity and economy, and in that case n is greater than 1. So, now you understand what is a transit unit. Now, there are newer buses that are called articulated buses that may have two coaches that are combined with each other. In that case n would be equal to 2. That is why here we have underlined that buses usually operate as single vehicles. Nowadays, we have newer buses that may have two coaches. Next is to understand the frequency of operation. Now, we as passengers are always interested in this frequency. We always want to know when is the next bus coming or when is the next metro rail coming. So, how do we operationally define frequency? It is defined as the number of transit units passing a point on a transit line in one direction in 1 hour. Okay. So, it is a number of transit units passing a point on a transit line in one direction in 1 hour. So, the frequency of operation f on a transit line is usually expressed in terms of TU per hour. And similarly, if you just want to calculate the number of vehicles passing a fixed point, it is f times n. So, that is the frequency of operation. Now, when we say fleet, what do we usually mean? So, fleet is nothing but a collection of all the transit vehicles, buses and rails together. So, a city, a particular city may have different types of vehicles that offer public transportation. So, you may have buses, you may have some cases in cities like Kolkata, you have different types of buses, mini buses, air conditioned buses, many of the cities also have air conditioned buses now. So, these kind of all of those vehicles and buses put together along with the rail, you would collectively call them as fleet. So, when we are talking about how efficient is a public transportation network in a city, we usually see what is the fleet size. So, all of these vehicles put together, what is the size of the fleet. So, the fleet size can also be now calculated as the total number of vehicles needed for operation of a line or of an entire network. Okay. So, we have to have a minimum number of fleet size, otherwise we may not be able to meet the demands of the people residing in the city. So, the fleet size now consists of 3 different elements. One is N, which is the vehicles for regular service. So, during morning and peak hours, morning and evening peak hours, you need N number of vehicles to meet the demands of your citizens in the city. Then comes NF or NR and sub R, which is the reserve vehicles. So, you always have to have some vehicles reserved in your fleet, so that if some other vehicle breaks down or you need additional vehicles to meet additional demand on certain days, you always can use these reserve vehicles. And then there are vehicles which are classified as N sub base M, are vehicles in maintenance or repair. So, sometimes when it breaks down, there are different vehicles that go into maintenance and repair. So, all of these 3 types of vehicles collectively can be called as fleet size or collectively determine the fleet size. Now, there is a terminology called fleet utilization factor, which is usually used by the transit operators and is defined as the percentage of fleet available for service. So, like we saw and in the earlier slide, there may be a lot of vehicles that are in maintenance or repair. So, which will not be available for service. So, an utilization factor is defined as nothing but the summation of N, which are the normal vehicles in service during peak hours, plus NR, the reserve vehicles, divided by NF, which is the fleet size. So, based on how many total fleet size you have would be on the denominator, and the numerator would have your regular fleet fleet for peak hour travel and as well as the reserve vehicles. So, that the ratio of that gives you the utilization factor. The other important terminology to remember in public transportation is headway. Now, headway is the time interval between the moments 2 successive transit units pass a fixed point on a transit line. So, sometimes we interchangeably use headway and frequency, which have to be carefully looked at. They are related to each other, but when we interchangeably use it, we may not be doing the correct thing. So, headway is, so again the definition is the time interval between the moments 2 successive transit units pass a fixed point on a transit line. So, there is a transit line which will have a lot of vehicles. When one vehicle passes a point, the point could be a bus stop, and when the next vehicle passes that same point on the same line, so the same bus stop on the same line. So, the distance between those two, or the interval between those two, not the distance. Headway is usually expressed in terms of minutes. So, this will give you the headway. So, passengers expect short headways, whereas transit operators want long headways. So, we always want the next bus to come very quickly, right. So, we expect shorter headways, whereas it is very difficult operationally or very expensive operationally to have lot of vehicles coming in. So, usually transit operators want longer headways. So, there is always a give and take, and an optimal headway value is usually reached. Usually you would see that if the headways are greater than 6 minutes, then it is desirable to have values that can be divided by 60, because an hour has 60 minutes, and then you can always remember when the next bus comes. So, those are usually called clock headways, and it is easy to memorize. So, if you divide by 6, so you could say that the bus comes at 7 minutes past, 7.5 minutes past the hour, 10 minutes past the hour, 12 minutes past the hour, 15 minutes past the hour. So, these are usually easy to memorize headways. There is something called a policy headway, which ensures that the longest headway is scheduled determined based on the minimum level of service provided. Now, since the operator always wants longer headways and users always want shorter headways, so there is always something called a policy headway that ensures that the users are not disgruntled, at the same time the operators do not face excessive cost in running the transit operations. So, there is a headway which is an intermediary point, and it is called a policy headway, which has to be met so that the level of service is maintained. What is level of service? We will look later on. And then the minimum headway of a line is determined by physical characteristics of the line, like boarding, alighting rate, etc. Now, there is also a minimum headway that has to be met, and what do you mean by boarding, alighting rate is that if there are a lot of passengers boarding or alighting from majority of the stops on the line, then it actually affects how quickly a vehicle can come and leave that stop. So, that will affect the headways. So, there has to be a minimum value that we have to keep in mind. We have already looked at frequency, but let us look at how frequency and headway are related. So, frequency, as we know, is the number of TUs passing a point on a transit line in one direction in 1 hour, and here is how frequency and headway are related. Frequency and headway are just in the inverse of each other. So, it is 60 divided by h, h is the headway. Sometimes we alternatively use other indicators instead of frequency, we say spacing or density, but frequency is mostly what is used along with headway, but we have to remember the subtle difference between frequency and headway. The last two elements to remember in this lecture is capacity and utilization. So, the capacity or offered capacity of a system referred to its maximum ability to perform under prevailing conditions. So, any transit line would have a capacity, right. It has a capacity to operate n number of TUs, it has a capacity to move n number of people from point A to point B. So, that is essentially what is called offered capacity. Okay. So, there are two types of capacities, one is vehicle capacity and the other is line capacity. So, the vehicle capacity is the vehicle that is running on that line, how many spaces are available within that vehicle. Okay. So, the maximum number of spaces for passengers a TU can accommodate. So, sometimes we count only the seats, but sometimes we also count the seats plus standing spaces. Sometimes we say the ratio of the seats to standing spaces determine what is the vehicle capacity, whereas the line capacity is the maximum number of spaces that can be transported past a fixed point in one direction during an hour. So, when we add up all these different types of vehicle capacities, then we can calculate the line capacity. And then the utilized, so these two were offered capacities. Now, what is utilized capacity? Utilized capacity is nothing but the demand, which is the maximum number of passengers that are actually transported per hour. So, there is always a difference between what is offered capacity and what is utilized capacity, or in other sense there is a difference, but we also want to keep them close to each other. So, we want to keep that ratio, also known as the load factor or the capacity utilization, very close to 1. If it is very close to 1, then we are operating at optimal level of service, whereas if the offered capacity is very high, whereas the utilized capacity is very low, then the load factor is low. So, we understand the difference between offered capacity, utilized capacity, and how both of them are related is through capacity utilization, which is the ratio of utilized to offered capacity. So, in conclusion, we looked at the different types of lines, network, stops and stations. We also made some distinction between the different types of right of ways, which will allow you to understand how different types of public transportations operate. We looked at what is the difference between stops and stations, how the stations differ between when they are terminal or when they are transfer stations. We looked at the basic unit of transit, which is transit unit TU, looked at fleet size, different vehicles, and finally looked at capacity and utilization. So, now I would like to refer you to this textbook called Urban Transit Operations Planning and Economics by Vuk and Vucic. This would be primarily the textbook that will be used for all the lectures on public transportation, and you would find a lot of reading material in this textbook. So, I would request you all to get it. Thank you.